Let's have some fun. I want to make this little eyeball glow with a red LED. And what I've got here is just a little square Kleenex box. So I'm going to just make a real simple little project here that you might want to replicate to just have a little bit of fun, learn a little bit about electronics, and play around with a cute little prop. Okay, first thing I'm going to do is get rid of my little black paper here, and then I'm going to find the center of that box. So then what I'm going to do is just punch a little hole. I just love these pick set. I've got this pick set. I've got just, I don't know, I think 4 or 5 of these different angles. One is straight and several are different angles. And they just come in so handy for a variety of things. So I'm just going to use my straight one here and just punch a hole in my Kleenex box. And my plan will be to paint this box black to make it look a little bit scary and eerie with probably acrylic paint. So then what I'm going to do is mount my little eyeball there. And what I'm going to do is put an LED, a red LED up from underneath to light up the eyeball. So what I need to do then is find an LED, and I'm just going to take a standard red LED. Okay, so I am going to want to put the LED in the cavity of this thing, and I'm going to want to extend it up a little bit. Let's get that little beauty wired up first. What do you say? Normally I would use stranded wire, but because I want to have some support for that LED, I'm going to use solid wire, which is commonly called hookup wire. And I have this convenient little box full of it. It's kind of nice. And what's inside here is just a bunch of rolls of solid wire. And this one is 22 gauge, which is a touch heavy for most of what I do. I like to use 24 gauge or even 26 gauge in a lot of what I do. But this would be great for this project because it's quite stiff. And it holds a shape much better than stranded wire does. So that's the pro and the con, one of several, of stranded wire versus solid wire. Solid is stiff, stranded is flexible. And in this case, I want stiff. In most cases, I want flexible. So I am going to bring up my LED into the cavity of this thing a certain amount. And then I want to have some leeway. And from here down I could have stranded wire for the flexibility. But just for kicks, I'm going to stay with solid all the way down. And I'm using red to represent positive. So I'll go there with red, and black or green are typically representations for negative. And we'll use green today. And we'll just match that length and take a green solid wire. Okay. And then what I need to do is solder my LED to this along with a resistor. And I'm only going to use 2 batteries. Here's one that I have wired up with a standard female connector. It makes it a lot easier for me to plug it into my little test projects with 2 AA batteries. And many of these products that I use in my projects I have for sale to make it convenient for people to obtain. So I have these on my website if you go check that. Okay, so I was just saying I'm going to use 2 AA batteries. And if they're 1.5 volts each, that's 3 volts. In a perfect world, that would be 3 volts, but these batteries are never truly 100 or 1.5 volts. So it's going to be something less than 3 volts. And I have a tutorial on figuring resistors and voltages and stuff for LEDs. But take my word for it, today with a 3-volt power supply and a red LED. But I'm going to try to run this at somewhere around 20 milliamps maybe. With a 3-volt power supply, a red LED, I'm going to use a 100 ohm resistor to limit the current through the LED and not suck too much juice out of the batteries. Let's see how that works out. So I'm going to strip a little insulation off the end. And if you hadn't noticed my hands, I have arthritis, so I find it much easier to do it this way with a pair of needle nose pliers hanging onto it. And so there is solid wire versus stranded wire. When you strip wire, this is a real nice standard wire stripper, really cheap, a few bucks. And they're great. And what you often do is try to cut this just enough to get into the insulation, but not into the wire, and then pull off the insulation. But I have found it easier that I kind of tear off the insulation. I use the needle nose pliers as an anchor, and I just close it kind of around there, just because it's so easy to nick the wire. And again, because of my arthritis and stuff. So I actually just kind of use the needle nose as an anchor, and then I kind of just rip the insulation off rather than trying to cut the right depth without cutting the wire. That has worked out really well for me. It takes a little bit more time, but it's great. I can do that, and I rarely cut off the wire anymore where I used to cut it off or nick it quite regularly. And I've got a tool here called Helping Hands, which you want to get if you're doing any of this type of work. It's got two little, or maybe more. There used to be a magnifying glass on here, but it's got two alligator clips, and depending on what you get, you might get more or fewer. And I don't use a magnifying glass anymore. I have got the jeweler's lid on my head almost all day long with my old eyes now. So I don't use a magnifying glass. I just pull down the visor on this thing when I need to see better what's going on. What I'm going to do then is wire a resistor into this LED. And actually, instead of using the Helping Hands, I'm going to use a little contraption I made up, a couple of springs on it on a block of wood. And what I do is I just stick the stuff in that spring, and it works out really well. So I'm going to tin the wire first. Let's do that to 2 inches here. Let's do it to 4. What the heck? Both ends of the solid wire. I'm going to tin that too, as long as I'm at it. And tinning it just adds a little bit of solder to the wire and preps it so that it will solder to something else better, faster, easier. Cut off a little bit. These wire cutters are kind of big for these kinds of projects, but boy, do I love these big, heavy ones. I've also got all sorts of other ones. I've got little surface cut nippers for smaller jobs. And I have, this is probably more standard for doing the small wiring projects. Those are real nice. The spring return is really nice. You can get the real cheap ones that don't have a spring return. So I need some solder. I know there's different ways of saying solder. You pronounce the L or don't pronounce the L. It seems like people across the pond pronounce the L, but people in America don't. It's kind of like the word niche. Typically people in the United States call it niche, and others call it niche. So solder, take your pick. Okay, so I'm just going to tin up these babies real quick. So they'll take solder better later, they'll connect better. Life will be good. All right. So that's all ready to go. So I'm going to solder my resistor onto the positive lead. I'll tin my tip with a little excess solder, and that'll take care of it all. Here's how I do that. I just have a little piece sticking up here, and then I find my resistor again if I can. And I'll just put a little extra juice on my tip here, and then I'll solder these two things together. And I should actually cut off the leads of the resistor, of the LED while I'm at it. Okay, so now I have my little 100 ohm resistor soldered onto the my sun visor here, soldered onto the positive lead of the LED. And then I am going to put the solid wire on here that will make it solid enough and have enough support to put it up into the eyeball. And then I'm going to put the red wire on positive. And the green wire representing negative. Okay, look at that. And so now I've got stiff wiring that will support that thing straight up into the cavity of that eyeball. So before I get too carried away, I'm going to test this, just make sure that it works. So I've got my little power supply here. Actually, I'm going to get a different one. Here's one that I built that I can just easily touch the two metal pieces. So I resist my LED works. My connections are good. I can proceed. So what I'm going to want to do then is run this up through the box into the eyeball. So in order to prevent these leads from shorting, then I'm going to put some heat shrink over them. So let's see if I have got a piece of heat shrink here. Okay, there we go. Put that up there. Or I just take the barrel of the soldering iron. And I'm kind of pushing it up towards the LED so that it doesn't come down off of the bare wire. And there, that should stick. Now we can go up through the box. It's not going to be quite a big enough hole, so I'm going to make a little bit larger hole. And I don't really have to do anything to secure this, really. I'm going to hot glue it into the eyeball, I think. Now I'm going to hot glue it into the box. So I'm going to set the height that I want. And then if we put the eyeball over that, look, oh, that's going to be fun. Here I've got a little better solution. I've got alligator clips put onto these two AA's. And this one's got a nice little on-off switch. It's currently off, so I don't have to worry about shorting the leads. And let's put red to red and black, the other color that typically represents ground in the United States anyway. And let's put that on there, and let's turn it on just to be sure everything still works. Yes. And then what I'm going to do, let's see, I'm going to measure that to see if I like the height, and that looks about right. So that looks pretty good from the front. It's still awfully bright in here, but I think from what I can see in real life, it looks just about right. So for this silly little thing, I'm just going to leave it the way it is. So I have a little hot glue gun here that I think is ready to go. And then I am actually going to tack some down to the little eyeball here, just tack it down. So there's a fun little primer on how to make an LED work, how to solder in a resistor in series to protect the LED from drawing too much current and burning out, and using just a cute little 3-volt power supply. And again, see my other tutorial on how to calculate the resistance value and stuff for different LEDs and different voltages. I also show how to do it with a 5-volt supply, which is also very common. If you're going to connect something like this to an Arduino, which I'm going to do next, I think, in another project, so we can have a blinking eye, then that supplies 5 volts. And you have to be real careful about how much current you draw out of the Arduino. But I'll talk about all that in my tutorial on calculating resistors and LEDs and power supplies and stuff. And then if I were to paint this box black, that would be kind of a fun little, just a little toy, just something to practice with, to kind of get the hang of working with LEDs and resistors and power supplies.